So hello everyone, this is Ma'am Amano, and this lecture video is all about solving vectors by means of its components or just solving vectors. So let us review first the directions in a Cartesian plane with its corresponding signs. I have here the north, which is positive, east is positive, south is negative, west is negative. Now to warm up, I have here 60 newtons directed to the east and 40 newtons directed to the west. So this is your F1 or vector 1, but I will use the F since that is in Newton or force. And then 40 newtons is F2. And then to get the resulting vector or Fr, you just have to add, since they are in the same direction, both are going to the east. So you just have to add that. That is F1 plus F2. Therefore, you will have 60 newtons plus 40 newtons, that is 100 newtons. And you just have to copy the direction of the going to the east, since both of them are going to the east. This is your resulting force, 100 newton going to the east. Another example I have here, your F1 is 170 newton going to the east. And then your F2 is 110 newtons going to the west. To get the resulting force or resulting vector, you just have to, since they are in opposing direction, this is going to the east and this one is going to the west. Therefore, you need to subtract them. Whenever the magnitude is in opposing direction, you just have to subtract that. So to get the resulting force, that is F1 minus F2. Therefore, 170 newtons minus 110 newtons, that is 60 newtons. And then you have to copy the direction of the greater magnitude, which is 170 newton. Compared to 110, this is 1 is greater. So therefore, the direction is going to the east. Okay? And then another example, I have here your F1 is 30 newtons and your F2 is 100 newtons. This 30 newton is going to the east. This 100 newton is going to the west. Since they are in opposing direction, you have to subtract that. F1 minus F2 to get your resulting vector or Fr. And then therefore, 30 Newton minus 100 Newton, that is negative 70 Newton. But then you do not have to write the negative sign here. Since this one is greater than this one, you have to copy the direction which is going to the west. And west denotes a negative sign. So you do not have to write the negative here. That is understood. The resulting force, therefore, is 70 Newton going to the west. Another example, I have here 20 Newtons going to the west and 25 newtons going to the west. This is your F1, this is your F2, and to get the resulting force, that is F1 plus F2, since they are in the same direction. Whenever the magnitude is in the same direction, you just have to add that. If they are opposing, you just have to subtract. So in this case, this is F1 plus F2, 20 newtons plus 25 newtons, that is 45 newtons. Both of the magnitudes are going to the west direction, therefore that is 45 newtons going to the west. Another example, I have here 40 newtons to the north, this is your F1, 50 newtons to the south, this is F2. And then to get the resulting force or vector, you just have to subtract that since they are in opposing direction. Therefore, F1 minus F2 will be equal to Fr, and it is 40 newtons minus 50 newtons, that will be 10 newtons or negative 10 newtons. But you do not have to write the negative since the greater magnitude is going to the south, and south denotes negative sign. So therefore, you do not need to write a negative sign. You just have to specify the direction at going to the south. And then another example, I have here 50 newtons going to the north, your F1, and 40 newtons going to the south, your F2. To get the resulting vector, you just have to subtract that since they are in opposing direction. F1 minus F2 or 50 newtons minus 40 newtons, that is 10 newtons. And since the greater magnitude is going to the north, therefore your direction is going to the north. The resulting force is going to the north at 10 newtons. Another example, I have here your F1 at 2.5 newtons and F2 at 5 newtons. Since they are in the same direction but are going to the south, you just have to add that. Therefore, that is F1 plus F2 to get the resulting force or Fr. 2.5 newton plus 5 newton, that is 7.5 newton, and the direction is going to the south since both of them are going to the south. Another example, I have here 5 newtons going to the north, your F1, and 5 newtons going to the north as well, your F2. So since they are in the same direction, you just have to add that F1 plus F2 to get the Fr. And 5 newtons plus 5 newtons is 10 newtons, and the direction is going to the north since both of them are going to the north. So that is how you solve the vectors that are parallel to each other. Now, there are times that you need to add vectors that are not parallel to each other or antiparallel to each other. So these vectors are perpendicular with each other, meaning to say they are not in the same line. How do we solve this type of vectors? For example, I have here F1 is equals to 30 newtons and F2 is equals to 50 newtons. So if you will plot this line in a Cartesian plane that is in the x-axis, this is your F1, and your F2 is on the y-axis, upward. So how do we find the resultant force or resultant vector? When we say resultant force, the combined force of these two magnitudes here. So how do we find that? So we will be using the Pythagorean theorem, in which Fr or resultant force or resultant vector is equivalent to the square root of F1 squared plus F2 squared. So the value of our F1 is 30 newtons here. And the value of your F2 is 50 newtons. So that is 30 newtons squared plus 50 newtons squared, and then square root. 30 newtons squared is 900 newtons. 50 newtons squared is 2,500 newtons. Then add that, then find the square root. It is 3,400 newtons. Find the square root. The square root is 58.31 newtons. Therefore, that is the resultant force here. Okay? Here. And then how do we find the direction since they are perpendicular? How do we find the direction? To find the direction of that, you will be using the angle of reference. If you will notice here, it is placed in quadrant 1. In finding directions for perpendicular vectors, you have to follow this. If that is plotted in quadrant 1, that is equivalent to the reference angle. In quadrant 2, that is 180 minus the reference angle. In quadrant 3, that is 180 plus the reference angle. In quadrant 4, that is 360 minus the reference angle. And to find the reference angle, that is reference angle is equivalent to the negative tangent or inverse tangent multiplied to the y over x. Since this is plotted in the quadrant 1 as you can see here, therefore the direction is equivalent to the reference angle. So that is inverse tangent multiplied to the y over x. And then the value of your y is 50 here. And then the value of your x is 30. So that is 50 over 30. And then the reference angle will be 59.04 degrees. We can say that the resultant force is 58.31 newtons at 59.04 degrees since this is also the direction of the quadrant 1 vectors. So if you will plot this on a Cartesian plane, let me draw a Cartesian plane for you. Let us say this is your Cartesian plane. And it says 59.04. So we know that this one is 90 degrees. This is 180, this is 270, and this is 360. So half of this is 45, right? You may use a protractor if you want. And that is 59.04. So lalagpas siya ng kalahati. Mga nandito siya. Okay? And that is 59.04 yung direction niya. Okay? Now, another example for quadrant 1. Find the resultant vector of F1 is equals to 20 newtons. F2 is 40 newtons. If you will plot this on a Cartesian plane, F1 is in the x-axis, going to the east, and the y-axis is going upward, that is 40 newtons here. So how do you find the reference angle here? To find the reference angle, you will be using the same formula. And then the value of your F1 is 20 newton, then square that, and then 40 newton square that for F2. Then 20 newton squared is 400 newton. 40 newton squared is 1,600 newton. Then add that, and that is 2,000 newton. And find the square root, that is 44.72 n. Therefore, the resultant force or resultant vector is 44.72 n here, or newton rather. And then to find the direction, since that lies in quadrant 1, meaning to say the direction is equivalent to the reference angle in quadrant 1, that is inverse tangent multiplied to the value of y over x, and then the value of your y is 40 newtons here, and then the value of your x is 20, then that is 2, and then inverse tangent of 2 is 63.43 degrees. Therefore, we can say that the resultant force is 44.72 newton at 63.43 degrees direction. So if you will plot that in a Cartesian plane, 90 degrees, half of that is 45, and that is 63. So baka mga nandito yan. Gamit kayong protractor para mas tansya ninyo. Okay? So now let us proceed on solving vectors on quadrant 2. For example 1, find the resultant force and direction of F1 is equals to 15 newtons and F2 is equals to 48 newtons. If you will plot these two in a Cartesian plane, this one is going to the x-axis in the west direction here, F1, and then this one is going upward, meaning that is in y-axis, that is 48 newton upward here. So that is in quadrant 2. Now, to find the resultant force, that is square root of F1 squared plus F2 squared, the value of your F1 is 15 newton, then square that, plus the value of your F2 is 48 newton, then square that. 15 newton squared is 225 newton, then 48 squared is 2,304 newton. Add that, that is 2,529 newton. Find the square root, that is 50.29 newton. So therefore, the resultant force is 50.29 newton. And then to find the direction, first you need to find the reference angle, that is inverse tangent multiplied to the value of y over x. And then the value of your y is 48, the value of your x is 15. Then get the reference angle, that is 72.65 degrees. Since that is in quadrant 2, to find the direction, that is 180 minus the reference angle here. So 180 minus 72.65 from here, that will be 107.35 degrees. So if you will plot that on a Cartesian plane, mga nandito lang yung angle na yan, yung direction niya. Pero nasa quadrant 2. Okay? Ganyan mo siya ipa-plot. Tapos, another example, I have here find the resultant force and direction of F1 is equal to 20 Newton going to the west, and F2 is equal to 60 Newtons going to the north. And if you will plot that on a Cartesian plane that is in second quadrant, this is your F1 and this is your F2. And we have to find the hypotenuse or the resultant force or resultant vector. And to find that, we will use this formula here. So, resultant force is equivalent to the square root of F1 squared plus F2 squared. The value of your F1 is 20 Newton, then square that. The value of your F2 is 60 Newton, then square that. And then 20 Newton squared is 400 Newton. 60 Newton squared, that is 3,600 Newton. And then add that up, that is 4,000 Newton. Get the square root, that is 63.25 Newton. Now, to find the direction that is in quadrant 2, first we have to find the reference angle by the inverse of tangent multiplied to the value of y over x. And then the value of your y is 60, the value of your x is 20, then inverse tangent, the value of that is 71.57. Since that is in quadrant 2, to find the direction that is 180 minus the reference angle, and the reference angle is 71.57 here, subtracting that is 108.43 degrees. So therefore, the resultant force is 63.25 Newton at the direction of 108.43 degrees. So if you will plot that on a Cartesian plane, that is 108, right? So, mga ganyan. Okay? Let us proceed on quadrant 3 vectors. So find the resultant force and direction of F1 is equal to 65 Newton going to the west, and F2 of 135 Newton going to the south. Okay, so if you will plot that on a Cartesian plane, this is the F1 going to the west, 65 Newton. Going to the south, that is 135 Newton here. So we have to find the resultant force. To find the resultant force, that is the equivalent to square root of F1 squared plus F2 squared. The value of your F1 squared is 65 Newton, then square that. The value of your F2 is 135 Newton, then square that. And then 65 Newton squared is 4,225 Newton. 135 Newton squared, that is 18,225 Newton. And then get the sum, that would be 22,450, get the square root, that is 149.83 Newton. Therefore, the resultant force is 149.83 Newton here. And then to find the direction, first, reference angle is equivalent to the inverse tangent of y over x. The value of y is 135 and the value of x is 65 from here. And then get the value of the reference angle, that is 64.29 degrees. And then to find the direction in quadrant 3, that is 180 plus 64.29, or 180 plus the reference angle value, which is 64.29. And adding that up, that is 244.29 degrees. So if you will plot that on a Cartesian plane, 244.29 degrees, it lies here, somewhere here. Okay? And then another example for quadrant 3, I have here find the resultant force and direction of F1 of 70 Newton going to the west and F2 of 210 Newton going to the south. If you will plot that on a Cartesian plane, this is your F1, this is your F2. And as you can see, that is in third quadrant. To find the resultant force, you will be using this formula. The value of F1 is 70 Newton, then square that. The value of F2 is 210 Newton, then square that. 70 Newton squared is 4,100 Newton. 210 Newton squared is 44,100 Newton. And then get the sum, get the square root, that is 221.36 Newton. To find the direction, that is reference angle, is equivalent to the inverse tangent of value of y over x. Then the value of your y is 210, the value of your x is 70. That is 71.57 on your calculator. Then, to find the direction, that is 180 plus the reference angle. So, 180 plus 71.57 degrees, that is 251.57 degrees. So, if you will plot that on a Cartesian plane, the value is 251, right? So, mga nandito yan. Mga nandito. Ayan. Okay? Now, let us proceed on vectors on quadrant 4. Find the resultant force and direction of the following vectors. F1 is equals to 45 Newton going to the east. F2 is 60 Newtons going to the south. If you will plot that on a Cartesian plane, this is your F1 and this is your F2. We have to find the hypotenuse or resultant force using this formula. The value of your F1 is 45 Newtons. The value of your F2 is 60 Newtons. And then, 45 squared is 2,025 Newton. And then, 60 squared is 3,600 Newton. And then, get the sum, that is 5,625 Newton. Then, get the square root, that is 75 Newton. To find the direction, that is, reference angle is equivalent to the inverse tangent, and then the value of your y is 60, the value of your x is 45. Then calculating that on your calculator, that is 53.13 degrees. To find the direction on quadrant 4 vectors, you have to 360 minus the reference angle, which is 53.13. Subtracting that, that is 306.87. Now, if you will plot that on the Cartesian plane, On fourth angle, that is here, 306. Right, this way, here. That is the direction. So therefore, that is 75 Newton at 306.87 degrees. Another example for quadrant 4, we have here, find the resultant force and direction of the following vectors. F1 is equals to 55 Newton going to the east. And then for F2, that is 320 Newton. If you will plot it on a Cartesian plane, F1 here, F2 here, and then find the resultant force here. This is the formula. F1 is equivalent to 55 Newton. F2 is 320 Newton. 55 squared, that is 3025 Newton. 320 squared, that is 102,400 Newton. Get the sum, that is 105,425. Get the square root, that is 324.69 Newton. Now, to find the direction, you have to use the reference angle, which is equivalent to inverse tangent. The value of your y is 320. The value of your x is 55. Calculating that on your calculator, that is 80.25 degrees. Now, to find the direction on vectors on quadrant 4, that is 360 minus the reference angle, which is 80.25 degrees. Getting the difference, that is 279.75 degrees. If you will plot that on a Cartesian plane, that is in third quadrant, that is 279, because up to third quadrant, that is just 270. More than the value of that lies already in the fourth quadrant, so that is 279.75. It's here. Okay, so that is all for solving vectors.